Hello everyone, and welcome back. We are going to continue on our discussion of the for loops. And this time we're going to talk about the for loops with range. So let's go ahead and get started. So you can use for loops with the keyword range. So we would be for some variable in range, and then we would specify what that range is. We would specify the start, the stop, and the step size over which the range should operate. It includes the start index, but not the stop index. So it goes up to, but not including, just like when we're doing the slicing. If start is index is omitted, it will be assumed to be 0. If the step is not specified, 1 will be assumed. In other words, if one index is provided, it will start at 0 and index up by 1 up to stop. If 2 indices are provided, it will start at start and go up to stop with a step size of 1. And 3 indices are provided, it will start at stop and go up to stop with a step size of step. So this is our syntax for variable in range. We will have our parentheses and the colon, and then a start, stop, and step, which will all be integers, will be specified. So it's probably helpful to take a look at what this would actually look like, because that is a little bit difficult to imagine. So let's see if we have for I in range 3, print I, then we will cycle over 0, 1, 2, and we will print these out. For I in range 12 to 15, print I will have start at 12 and will go up to, but not including 15. And here we are simply just printing those out. And now finally, for I in range of 2, 11, 2, print I, we will begin at 2. We will go up to, but not including 11. And we will be counting by 2s. And we will print I. So this will go 2, 4, 6, 8, 10. We will stop because the next one would be 12. We go up to, but not including 11. So 10 is the nearest one. So that is where that will stop. Here's an example of putting that into a function. Here we're going to do count by 5s with parentheses. So this will not take anything in, and it's not going to return anything. It's going to count by 5s through 50. So here we have for I in range start at 5, up to but not including 51, and count by 5 and print I. So here's our function call. So I will start at 5, as we see right here, and then it will say, have we gone up to 51 yet? Is 5 less than 51? Yes. So we print I, and then back to the top. We will increase our I by the delta, which is 5. So we get to 10, print I, which will give us 10. Back to the top of the loop. I will now be 15, still less than 51, and so on. 20, 25, 30, 35, 40, 45 is still less than 51. Print 45. Back to the top, we increment up by 5. So now we are at 50, which is less than 51. We print I, and we see that if we add 5 more, we will be over the limit. So 50 is the last one that's within the 51 limit. And so our loop will terminate. So this is just a little bit more breaking this out, maybe in a little bit more detail for us. And this is working with this interactively. Again, we'll have that loop variable in range start, stop, and delta, and then just having this very simple one. This would cycle over from 0 up to 3 with the delta of 1 to give us 0, 1, and 2. So the loop variable must be of type int. The start must be an integer at which the loop variable begins. By default, that would be 0. The stop would be the integer to which the loop variable counts up to. It does not include the stop value as we have seen in these examples. And delta is the number to count by, so by default, that will be 1. So let's just take a look at how we can work with the default values, just breaking this out for you. If 3 parameters are specified, they will be taken as start, stop, and the delta. and then we could just print that. So what this one means is we start at 3, we go up to but not including x equals 9, and we will be counting by 2s, and then we could print x. So this will give us, starting at 3, right? Print out 3. We increment by 2, so now it's equal to 5. We print out x, back to the top. X increments by the delta, so 5 plus 2 is 7. We print the 7, back to the top. And we have now gotten to 9, but 9 is equal to 9. And using range, it goes up to, but not including that value. So we now stop and the loop terminates, and that is the end. So that's how that would work when you specify all 3. Now you could just specify 2 parameters. So let's just break this out in terms of what this actually means. So for x in range 2, 6, so start, stop, and delta, but we only have 2. So this is equivalent to this loop that I have put out for you over here. And so let's think why this might make sense. Well, the reason is because the most common thing we'd want to do is to count by ones, right? So we probably want to specify the start and stop, but most of the time we probably want to count by ones. So that's the first one that you can omit, and it will substitute in counting by ones automatically because that's the default value. So this says to begin at 2, go up to but not including 6, and count by 1 by default, whereas here we've explicitly said that. And we can see then that the loops produce identical output. But if just one parameter is specified, it will be taken to indicate the default to start at 0, to stop at the specified parameter, and a default delta. Oh, sorry, this should be delta of 1. And so here we're going to have for x in range 4. So we will start at 0, we'll go up to but not including 4, and we will increment by 1. So here we can see that this is what will happen. We will count by ones to loop over this. So it makes sense that the thing that we need to specify most often is the thing that we're going to count up to, right? You can't run the for x in range loop without saying what you're counting to. You have to count up to something. And so that's what the for x in range with just a single one is for. So this one now has the implicit delta being 1, and that we would start at 0, which is most of the time where we would want to begin, which for Python, of course, is the beginning index. We can also use looping with numerical indices to process strings. What we mean by this is we can use such loop types in order to actually process our strings. So here we have def, and we're going to have a function called bees of s. This function is going to take a string input. There's a string right here from our function call, and it is going to return an integer. It's going to count the number of the character b in a string. So how would this work? So what we're going to do here is we're going to have our accumulator equal to 0. You might say, well, you know, we usually have the accumulator equal to the empty string, right? Why is it equal to 0? Well, the reason is because we're trying to accumulate the number of times that something occurs. So the default getting started with not having accumulated anything means that you would start with the integer 0. So for x in range, the length of the string. So notice that what we're doing is we're using a for x in range style of loop. And here we're going to use the length of the string. So this will provide Python with the upper limit. Now remember that when we take the length of the string, that it will count starting with 1, just as we would start counting with 1. So that when we are doing up to but not including it, by doing it out to the length, which is 1 more than if we started with 0, effectively we have the whole string. So this actually works really well with beginning with the index of 0, because otherwise you have to do a length of s plus 1, but you don't because of the 0 counting start. So this works really well. So this will provide Python with the maximum number that it should go up to, right? So remember the start, stop, and delta. So this is the case where we simply just provide 1, which we remember means that the start will be by default 0, and the delta by default will be 1, and then that the number we're providing will be telling us about the number to go up to, but not including. Now, X is going to be numeric. Do you agree? So in the beginning, the X will begin at the default position, 0. If S of 0, oh, it's slicing. If S of 0 is equal to B, our accumulator, which is numeric, and right now is equal to 0, will be incremented by 1 with augmented assignment. Here is our string. Is S of 0 a capital B? It sure is. So we'll collect that, that count right here, and we go back to the top of our for loop. So X now is advanced to the 1th position, E. So S of X is S of 1, which is E. That is not equal to B. So this branch guard is false, so we don't add anything to the accumulator. So the accumulator remains at 1. We go to the next X. So the 2th position, that's a space. S of 2 is the space not equal to B. So we don't add anything to the accumulator. Now we get to the 4th position. If S of 4, 0, 1, 2, 3, A, is equal to B, which it's not, then the accumulator won't do anything. We go up again. Now we're at 5, which is the space. Space again, that's not equal. So we come over here, and now we get to the 0, 1, 2, 3, 4. So we get to the 6th one, I think. I'm starting to lose count. 0, 1, 2, 3, 4. Oh, this one is the 5th one. Sorry, I think I may have said the wrong number the last time through. 5 lands on capital B again. So S of 5 is playing out the 5th one, which is capital B. That is a match. So we will add 1 to the accumulator. So now the accumulator has up to 2 because we've now encountered 2 B's. And so we continue on like so. When we land on this B right here, we will add that up to 3. And so our accumulator, as you can see, will be collecting then all of the counts for the capital letters. And now we can return the accumulator after we have completed processing the string. And the accumulator will be equal to 3, which we see over here. We can also process strings with while loops. So let's see what we might do in this case. So we had B's last time, now we have fees for F's. We are going to take this tongue twister and we're going to count the number of F of any case in a string. So that means capital or lowercase f. How many of them are there in here? And I think there are 6. 1, 2, 3, 4, 5, 6. You always want to make sure you know what the answer ought to be so that you can run a test case in Python and make sure it's behaving as you expect. So I am expecting 6, and I also see the 6 up here. So let's see how this is going to work. I have my count is equal to 0, and I have my I equal to 0. So count is going to be for counting my F's encountered. And the I is going to be for the loop variable, right? So the loop variable and the counter need to be independent because the number of times through the loop is not necessarily going to be equal to the number of times that I have encountered an F. So now we're going to have this set up while I is less than the length of the string, right? So again, this will give us this numeric idea. Length of S will be the numeric length of that string that we're going to process. Just like we did before, we're going to take a slice, S of I. So that is going to be S, and then we will substitute in the I for the numeric index. Now we're also going, so do you see that this is going to then pull out a character, right? So S of 0, which will be our first one, will be the capital letter T. But we want it to be case independent. So what we can do is we can pass it through the dot upper. So here we have a capital F, but here we have lowercase f's, and we want all of them to match. So we'll run it through dot upper, and we'll see if it is equal to the capital letter F. We could have also run it through dot lower, just like we saw when we saw the built-ins for strings. Pass it through the dot lower, which is fine. We will increment our counts. So, and also we have our I plus equals 1. This is for our looping variable. The while I is less than length of string, this one controls the looping. So again, we have these two independent counters going on. The I indexing the loop itself, which here we're checking to see if it's less than the length of the string, and here's how we advance that loop. And we have our counter, which will advance if this condition of the branch guard is met in the if statement. So this will only increment when we have encountered an F. And again, the F in case sensitivity has been removed because we've run it through dot upper. And so we cycle over this tongue twister, and we will calculate out that there are 6 F's, because it will be S of 0, 1, 2, 3, 4, 5, 6, 7, 8, right? S of 8 will make this statement true. And then again, when we get to F in fairly, and then far, fine, flying further, will also make the counts be incremented. All right, well then, I hope that the processing with the for X and range style has been made clear for you. I know that this can be kind of a confusing topic, so we did have quite a few examples today. So I hope that that has been helpful for you to see how those work. And also we have just seen now how we can use some of our other kinds of looping to also use numeric indices to process things. So for X and range is really helpful because that allows us to use the for loop with a numeric index that also automatically increments, kind of like when we cycled over the strings, that index automatically became the character, right? So the major difference is whether our looping variable becomes the character itself, or if it is a numeric variable, which then needs to be incremented. So in the while loops, we need to increment those explicitly ourselves using I plus equals 1, for example, whereas in the for X in range, the X will increment automatically as it actually cycles through the looping. The for X in range is unique because it does allow us to make use of the incrementation for something besides 1, right? So that's always really nice to be able to do that in an automated kind of a way. All right, well, I hope that this has been helpful for you to see how some of these things work. We'll continue on in the next time looking at some even more examples of these, and we'll also be looking at comparing and contrasting between the different kinds of loops. And we'll also be talking about interconverting between those loop styles. All right, then we will see you the next time.